welcome all the delegates. I shall be speaking for the industrial water security through conjunctive use of the surface and groundwater and present the case studies of Asahi India Glass Limited, explain how we implemented it successfully on two studies done together with the GWMICC. The industrial water security is the ability of an industry to ensure a reliable, sustainable and high quality of water for its operations regardless of the seasonal variations. Conjunctive use is the coordinated management of surface water, rainwater, rivers, lakes and groundwater aquifers. Is a primary strategy of achieving it. The fundamental principle of conjunctive use is to treat the surface and groundwater as a single entity. The difference is during the wet season, the surface water is the primary concern. The industry maximizes the use of the abundant surface water by direct use with collections in the ponds, tanks, and the surplus water is directed to aquifers through the rainwater harvesting to deposit in groundwater reservoirs. During the dry season, when the surface water reduces or unavailable, the industry withdraws the water from the groundwater through aquifers. The strategy which is adopted by the industry is to assess the total requirement of the water of industry for the present and future and availability of water from the different sources and then prepare the management plan and implement for the industrial water security through conjunctive use of all available water. Asahi India Glass approached us in the year 2023 for their upcoming project in the Ranpur, in the Soniana in Chittorgarh. Their requirement was 300 kiloliter per day, and the main point was the water availability in that area in the groundwater was not available, and it could not meet out the complete requirement, and the glass industry could not run for a single day without availability of this much amount of water. So this much quantity was required on the firm basis. These two studies were done by us, with the GWMICC carried out all the studies. The first study was done in the project area for hydrological, hydrogeological and rainwater harvesting, and the second study was done for the groundwater potentiality of selected RICO area and portion of the Banas River. It was done out of the project area. This is the DM of the project site, drainage map. This is the hydrological, hydrogeological rainwater harvesting studies. The hydrological studies consisted of collection of the annual rainfall, number of annual rainy days, peak daily rainfall of 66 years to work out the average annual rainfall, etc. The total runoff potential from the project area of 365,987 square meter worked out to be 1,28,496 cubic meter, which was more than the annual requirement of the industry, 1,09,500 cubic meter. The peak daily runoff and the total peak runoff were calculated. So, how we implemented? The rectangular drains were designed with the base width of the 1.67 meter and the depth that was 0.9 meter and the slope was 1:800. The three alternative designs were suggested, out of which the design second was the approved. It was having the 380 meter length, 18 meter width and 8 meter depth with a storage capacity of 54,720 cubic meter and 4 number injection wells with recharge in the groundwater. The direct utilization of water could provide 1,12,860 cubic meter per annum, and the recharge capacity of 8580 cubic meter could be generated through the injection wells. This was a design which was the approved design, and you can see the rectangular tank with the 4 injection wells. So up to the 5.5 meter depth, the water could be stored at the dead storage, and 2.5 meter was open for through the V wire filter to go to the groundwater and be used in the afterwards. This is the layout plan of the approved storage tank and the drains. Hydrogeological studies consisted of recharge test studies, seepage studies, ATM tests, and subsurface investigation, and these sites were found to be the best for abstraction of the groundwater. These are the geological investigation diagram of the 2Ds and 3Ds. This was the net result. The total runoff potential based on the average rainfall was 1,28,496 cubic meter per annum. The dead storage was 36,620, and direct utilization, assuming the tank will be filled for 3 times, it was 1,12,860 cubic meter. The balance runoff was taken as 65 cubic meter per well, so 260 cubic meter. So annual recharge was 8580 cubic meter. After this, the project authorities approached again us and asked for the revised requirement of the 400 kiloliter per day, and they required it for their future expansion also and meeting the shortages of the project site. The studies were to be done in the adjoining RICO area of 1 kilometer into 2.5 kilometer and Banas River 1 kilometer 200 meter. The various studies were done by GWMICC. Topographic survey by the DGPS and total station. The first strategy was to have the topographic survey by DGPS total station in this area, 1 kilometer, 2.5 kilometer in the RICO area, and 1 kilometer 100 meter in the Banas area. On this basis, 3 ponds were selected with a storage capacity of 1,36,905 cubic meter. These are 3 tanks which were suggested for the storage of the water, and this is the Banas River, and these are the contour maps. The Banas River this is a geologic sounding pipe, and the Banas River analysis with the current meter location. Geoelectric scanning for the hydrogeological studies with 400 as ADMT, and soundings done at the 65 points with the aquameter CRM 500 for a 250 meter depth, and also in the Banas River bank with the aquameter CRM 500 in the 50 meter into 1 kilometer for depth of 50 meter done at 30 points. These are the 2D maps of the 64, 53 and 51 in the RICO area, and R13, R25 on the Banas River bank, and these are the fence diagram, 3D maps of the RICO and Banas area. The selection of sites for withdrawal of groundwater, 64, 53 and 51 were found as the best sites in the RICO area, and R13, R25 in the river bank. The radial collector well for the site R13 was selected. This is the radial collector well for site R13 at Banas River, and that's another one is the Banas River, and the construction of these radial wells, and from there it would be stored in the this storage tanks and will be taken to the this project site. So this was the suggestion. So this was our total study with the total water availability from various proposals. Ponds 1, 2, 3 with the depressions in the RICO area with 95,000 cubic meter per annum. Principal aquifers in the RICO site 64, 53, 51 with 0.14 MCM per annum, and principal aquifers in the Banas River sites R13 and R25 more than 400 cubic meter per day. So, and radial collector wells, 2 numbers were suggested for a subsurface water from the Banas River, and it could provide 800 cubic meter per day. And the interesting point was this subsurface was a most for availability of the water. With all these things were given to the project authority, and they could use any of these alternatives depending on the economics. Thanking you very much. The one thing which I would like to say, this I had to speak in the beginning, is the very, very special thanks to Jain sir, and I learnt a lot with Jain sir. It was a wonderful opportunity to work with him. फर्स्ट थिंग, सेकेंड थिंग, आज पानी के बारे में काफ़ी बात हुई है. मैं आपको एक बड़ी इंटरेस्टिंग बात बताता हूँ जो कि कुछ अलग है. क्या आप बता सकते हैं हमारे सोलर सिस्टम में सबसे पहले पानी कहाँ था? वॉज इट अर्थ? नो, इट वॉज मार्स. मंगल पे सबसे पहले हमारे सोलर सिस्टम में पानी था. आज वह पानी नहीं है. कल यही चीज़ क्लाइमेट चेंज के साथ हमारे यहाँ भी हो सकती है. तो ये आज का सेशन बेहतरीन, बहुत ही अच्छा था. एक जागृति के साथ में सबने अपने अपने तरीके से पानी की इम्पोर्टेंस के बारे में बताया. आई एम देवेंद्र शर्मा, फाउंडर एंड CEO ऑफ WS इनिशिएटिव प्राइवेट लिमिटेड, एंड थैंक यू वेरी मच.